Hello. Welcome to my video. Yeah, so I heard that you missed a few of your lessons, yeah, on enthalpy change. So I just made this video to help you recover what you missed in class. Yeah, so let's begin. So enthalpy, let's start with a simple recap on what it is, yes? So basically, enthalpy change. Firstly, what is enthalpy? Enthalpy is total amount of thermal energy in a substance. It's not heat energy. Heat is the kinetic energy in the substance. Thermal is a different kind of energy, all right? So it's different in a substance, basically what it is. Okay, and then let's move on to enthalpy change. You see, enthalpy has the H, and it's just enthalpy, the symbol for it. And then here we have delta to symbolize change with the H. So it's the energy released to or absorbed from the surrounding during the chemical or physical change. Basically, in a reaction, um, it will tell us if enthalpy change in the end result is positive. That means it's endothermic thermic reaction, meaning heat is absorbed heat. All right, sorry for the bad handwriting. All right, if enthalpy change is negative, that means it's exothermic. That means heat is lost. Sorry, not heat. Energy, just energy. Could be heat, electrical, whatever. It's just lost. Yeah, lost. Lost. There we go. Energy lost. Yeah, that's right. Energy. 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 Okay, cool. And move on. Let's move on to the next part about learning the two other ways of enthalpy change. I heard that you learned Hess law already. Okay, enthalpy and bond energies. This is one way out of the two to calculate the delta H. All right, so firstly, we'll see here delta H equals the sum of bond energies of all bonds in reactants, meaning the reactants, let's say NaOH plus HCl, okay? And then it would give us, this is neutralization, so NaCl plus H2O, basic, simple. So what we do here is we take the sum of the bond energy, we take the energy of this guy and this person, we add them together, and we'll get the sum of that bond energy times the bonds broken. Basically, this is just 1 to 1, so nothing really multiplies here. And here's that NaCl plus H2O. So we'll take the energy of this and energy of this, add them together, and then in total we just minus this sum with this sum, and then we'll get enthalpy change. Pretty straightforward. Let's try an example. All right. So this is an example. CH3, yeah, plus Cl2. So a breaking of CH and Cl bonds. So first it will be delta H to it will go up. So energy is gained, yeah. We split it, and then H plus CH3 plus Cl plus Cl. And then for step 2, we make the new bond. So CH3 to Cl, and then H to Cl. We'll get CH3Cl and HCl. This is H1 and H2. We got both, but we want to find this now. How would we do that? We would actually just take H1 minus H2. Basic, it's exactly what's written here. H1 and H2. That's what it is. So here they give us the numbers. We just take these numbers. We write this first. We get this. We write this down. And then we just plug these guys in here. Pretty simple, straightforward. And here is what we get. We plus them. Okay, 413, 239, 339, 427. The minus in the middle. Okay, this extra step, you can skip this if you want, and we'll get negative 114. Pretty, there's not a lot of steps to go through here. It's just plug it in, and then you're done with that step. Straightforward. Okay, let's move on to a second one. This one's a bit more difficult, yeah? So CH4, 2O2, CO2, and 2H2O, yeah? So since we have this magical numbers here, 2 and 2, what will we do? So you see here, the bonds, they already gave us 4 times of this because there's 4H. And you would think it's just times that, yeah. Well, that's what you do, 4 to the 413. And then 2, since there's 2 here, we would times 2 and double bond O. Uh, yeah. And then 2 times the carbon dioxide because there's 2 oxygen in there. So we get that. And then we get 2 oxygen. We would times it by 4 because there's 4 hydrogen. And then that's a 2 right there. So we get that. We get this. We write this down. And ta-da! We get this. 4 to the 413 to this. And then we minus the long one. Yeah, just plug it in. Pretty simple, straightforward. And then we calculate the answer. We get negative 824. Pretty straightforward. Okay, moving on to the next step. Next type of change in enthalpy, the standard enthalpy of formation. Well, this is firstly what we need to know here. This is the compound is the change in enthalpy that occurs when 1 mole of compound is formed from its elements in their standard states. Pretty confusing, yeah, but don't worry. There's an example here. Okay, so let's ignore this half first. Okay, we got N2 plus O2. We get NO2. Yep, pretty clear here. It's just a formation equation here. Okay, so here you see standard enthalpy of formation. This is what we get uh, for NO2. So let's say if NO2 is a reactant in this case, and you get N2 plus O2, this will be flipped to be negative 33.2 kJ per mole. It doesn't matter what you do with it. You, if this, since this is a product here, it'll be positive. If you put it on this side as a reactant, it'll be a negative. So, but then this, you see this half here is just to balance it out because there's a NO2 and there's N2 here. So N2 times half would be N, and then you get balanced equation. Okay, moving on, standard enthalpy of reaction. So here, a table of standard enthalpies of formation. Uh, we'll look at that table next. So firstly, let's look at this equation here. H delta HR. So what is it? It's the sum of number of products, delta of the products, enthalpy change of the products minus the sum of the reactants of delta H of the reactants. Okay, so in this table, we'll look at it when we're doing equations and solving questions because they're just straightforward, just numbers given to you. Yep. Okay, look at this question here. Benzene burns in the air to produce carbon dioxide and liquid water. How much heat is released per mole benzene combusted Standard enthalpy of formation benzene 49.04, yeah? So just like this here, you see, this equation is very, very similar to the bond energy equation. So let's write this down. All right. What we have here is that C6H6 plus oxygen, we get CO2, H2O. Well, I just balanced it. And then here we have C plus H2, we got C6H2, H6. Yep. We balance it out, we get this. So you see, this is a product. Yep. So that's why it's positive here. But then if we want to use this here, we flip into negative. And then this O2 does not have a value here because it doesn't. In this section here, singular element has no value. Like you see here, carbon, it's just alone here. See, we get 0. That's why it's gonna be 0. So moving on here. Okay, pretty simple. Oxygen would not have a number. And then we look at carbon dioxide. Carbon dioxide, where is this? Carbon dioxide. We get negative 393.5. All right, let's write it down, 393.5. And then lastly, we have water. Water, where is water? Water's here, negative 285. And these are products. So like we talked about here, NO2, the number they give us here is the product. Whenever they give you a number, it's always the product, never reactant. Okay, if you want to make it into a reactant, just flip the number into negative, inverse it. So here we go, we get this, and we get total calculation, this plus this, total. So I'll take this total, and then minus this total. We'll get this. Straightforward, simple calculation. Very, very straightforward. Nothing too difficult. Straight. All right, let's move on to the next example, shall we? So, solid calcium oxide reacts with liquid water, produces calcium hydroxide. If the standard enthalpies of formation of solid calcium oxide and solid calcium hydroxide are this and this, respectively, calculate the standard enthalpy of the reaction. So let's write it down. All right. CaO plus, what does it do? CaO plus H2O gives us CaOH. Okay, let's look at this. Let's balance it out. H2, we got one H. So let's put 2 here. We get CO, Ca, and then we just put a 2 here. Easy, simple, simple. All right. Let's put this as solid, liquid, and then we get solid again. Okay, cool. So how would we get, we have calcium oxide. Calcium oxide, we have Ca plus O2 gives us CaO. So here will be 2 and 2. Total we'll get here is negative 634.9 kJ mole. Cool, cool. Okay, and then what we have here is CaOH. So basically, how this reaction was, we'll just take this as the final number here, 986.1 kJ mole. Okay, cool, 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 super cool. Okay, this is the final. We'll just minus the sum of this. CaO, and water. So we have CaO here. We'll just inverse this because now it's a reactant. 634.9 plus, what was water before? It was negative 285.8. So we inverse that, 285.8. Let's put that into our calculator. 634.9 plus 285.8 minus negative 986.1. Cool, cool, cool. We get 19.06. 1906, sorry, 1906.8 kJ mole. So, what does this tell us? It tells us it's a, hold on, wait. Okay. Yes, so that, I was just double checking something. All right, so this is correct. All right, all right, all right. And then that's about it, actually. Just these two steps. The two of these equations, both of the ways, just get the sum of the two sides and then minus them. It's really straightforward. Not a lot of confusion that can happen. Maybe like in the calculations, but overall it's not really that confusing. And hope you understood. Thank you for watching.